Okay, welcome to the second video from 8.4 of our identities unit. So this one will be 8.4 double angle identities. So let's just jump right in there. If you notice that this is 2 times x, so be careful. We talked about this before, that when you write sine squared x, you don't want to make it so look like it's this, because now you have an identity for that and it means double angle, okay? So these do not mean the same, so be careful. So what you want to look at, if you need to, like I did here, let me just erase this so it's a little neater, is that you can put this in parentheses so it looks like this, and so it's easier to know, okay, that stays together and whatever in there goes together. So the double angle for sine 2x, and how I expand that out, the identity for that is 2 sine x cosine x. Okay, we have a 2, I have a sine x and cosine x. So what I'm going to do is I'm going to kind of just prove this to you, and we're just going to start, and we're going to use our sum and different identities from the other video to see how this works. So if I write sine 2x, and this is what I have, I can break that up. I know that sine can be written as x plus x. So that 2x can be written like that. Mathematically, two like terms, I have 2 x's, I get 2 of them. So now what I want to use, though, is I want to use the sine, a sum identity. And I know that when I have that, that means that I have the sine of sine 2x equals sine of x cosine of x. Well, it's really y. And so if you think about it, sorry, I should have done that. This is your x and this is your y. So now it's cosine of x. So it stays the same value. Plus, because that's a plus, cosine x, which is x, times sine of y. And y for us is x. Okay, so now I just rewrote that. Now, how do I want to get this up here? That's what I'm trying to show you, that I prove that that works. So if you think about this, if you look at these two terms, they're exactly the same. If I rewrite, I'm just going to write this again. If I rewrite that second term and just switch the sine and cosine, I should have the same thing. And I can do that because they're being multiplied together, and multiplication is a commutative. So I have sine x, I'm going to write that first, times cosine x. And just like we were doing before in the 8.3, we're trying to make sure we understand these. These are two terms that are exactly the same. So if this was 1x plus another x, I have 2 of them. So now I have 2 sine x cosine x. I combine like terms. So here I rewrite this, and here I'm combining like terms. What we always do in math. So now we just shown how we got that. So that's one. Okay, now let's go to cosine. And when you pay attention to what you see when you get both of them, this will kind of help you what it looks like. So cosine double angle has 3 values. Okay, so the first one we're going to have is cosine squared x minus sine squared x. Might look kind of like your identity you have, but it's not quite the same. Okay, so we have a minus and not a plus. Okay, so this is my double angle. So I'm going to use the same idea up here, and I'm going to prove that to you. So if I have cosine 2x, and I want to rewrite that, that is going to be cosine of x plus x. Well, cosine is slightly different, because with cosine, we just have a cosine cosine and a sine sine. So for us, same thing. We have, this is your x and this is your y. So if I want to rewrite my identity using that x and x, I will have cosine x times cosine of the other x, which is your y, which is still x. Well, this is a plus though. So remember that means minus when it comes to cosines, the opposite. And then underneath we'll have sine x and then cosine x. Sine x. So that just leaves me now with this. Well, we know what cosine, these are the same thing. So cosine x times cosine x will give me cosine squared x. Minus sine x times sine x is sine squared x. And that's why that equals that. Now, the next one we have is 1 minus 2 sine squared x. Okay. So I'm going to use this idea here, this cosine squared x minus sine squared x. And I want to see if I can come up with this over here. Can I get this based on what I have? Let's see. Well, and we know about one thing nice about this. We know we want 2 of these sine squared x, and we want to get rid of cosine squared x. So how do I get this? Well, that's an identity. If I just look at just this portion right here, nothing else, just this one. Leave that thing over on the other side this way. I'm just going to rewrite it, excuse me, as this is going to stay as minus sine squared x. I'm not going to touch that. But what is cosine x squared x equal to? Well, from our identities, from our Pythagorean identities, cosine squared x is equal to 1 minus sine squared x. And then you're going to subtract that. So just kind of, whichever you need to say that this is this here, and so forth. So I can get rid of these parentheses because I don't have to factor or multiply anything in. So if I do that, I have 1 minus sine squared x minus sine squared x. Well, these are like terms. I have a -1 and a -1. That gives me 1 minus 2 sine squared x. And that's how you get this one. Okay. So now we're going to use the same idea to get the other one. Or our other identity for cosine double x will be 2 cosine squared x minus 1. So I'm going to use the same idea. I'm going to take this very top one up here, and I'm going to say I have cosine squared x minus sine squared x. Okay, how do I get just a cosine squared x over here? Same idea. I want to get rid of sine squared x. I have cosine, and I actually have 2 of them. So I'm going to use my identity, and I'm going to replace the sine squared x with 1 minus cosine squared x. And notice it's a minus parentheses here, and I'll bring the other one down because we didn't do anything with that. So be careful. I'm going to drop the parentheses, but in order to do that, I must distribute. So I will have cosine squared x minus 1 plus cosine squared x. Multiply, make everything the opposite in there. So now if we think about it, how many cosine squared x do we have? Here's a 1, here's a 2. So that gives me 2 cosine squared x, and then I have a minus 1. And that's what our identity is up there. So we're going to use these. Okay, so let's look how we're going to use it for making, using the double angle identities with what we have, okay? So let's look at this. So what we want to look at, just kind of like what we did with the plus and minus, sometimes you're given one side and you need the other, okay? So here I'm given this side, so I need to get what the other side is, okay? I have everything filled in. So I'm going to write the identity for this. It's a cosine squared, so it has to be the cosine double angle. And if you notice, Squares are only in the double angle for cosine, but not sine. So if I rewrite the actual identity underneath, so I'm going to write 2 cosine 2x. Made that too close. All right, so let's do this. Cosine 2x equals 2 cosine squared x minus 1. And if I look at it carefully, what is x? X is this and this. So for us, x is 15. So now I'm going to go and say, if I just say x is 15, I'm going to put that here. This is what I want to use. I don't care about the other part anymore because I want to get rid of what I can. I want to use the double angle identity to simplify. Okay, so that's what I'm trying to do, simplify. So now I know that x is 15. So over here, I can say cosine of 2 times 15. Well, 2 times 15 is 30. And the cosine of 30 is the square root of 3 over 2. Okay, let's look at number 2. Again, I'm looking at how I have one side, I want to get the other so I can simplify. So if I notice I have a 2 sine and a cosine, these x is the same, so I know this has to be the sine double angle. So the double angle 2x is equal to 2 sine x cosine x. Well, based on this, what we have, x is 30 degrees. Here's your x, and here's your x. So now let's just use it for this. I can't do anything else this, okay? So sine of 2 times 30 is the sine of 60 degrees, and the sine of 60 degrees is also the square root of 3 over 2. So that's simplified. Let's go on to the next one. Okay, so I see a cosine with a square and a minus 1, so this has to be the double angle for cosine. And so, again, if I think of what it looks like, cosine squared x minus 1. Well, what's x? X is this 3x here. 3x here and x. Those correlate, so that means x, keep doing that, x equals 3x. So now remember, this equals to 2 sine cosine double angle. So let's do this. In place of x, I'm going to put 3x. That right there. So I multiply that together, and I get cosine of 6x. And that's all I can do. Nothing else. Now the next part that we're going to do, we're going to verify. And you have to really think about what you need at the end here. So when you're trying to solve any of these, look at what this is. Think ahead. What do you need? Well, I have a cotangent. And these are sine and cosine over here. So if I write cotangent as cosine x over sine x, I need something like that. So I got to think of what I have. I need sine x's on the bottom. I need a cosine x on top, something like that. Maybe something cancel out. I'm not going to say that every time you pick something right away, it's going to work. You just have to start it. You got to start somewhere, okay? And so what we want to do is we use our identities. Well, we have a double angle here and a double angle here, okay? Notice that I can just do part of this. I can just figure out what that is. I don't have to have the whole bottom to be an identity that says, okay, that's got to be something, because it's not in any identities that we have. So be careful with that. Think outside the box on some of these. And as long as you're doing the right identity, substituting in, and you're doing the right math rules, like adding the fractions correctly, factoring, and so forth, then you should be able to solve what you need to do. Again, you may start some and it's takes you longer. You see somebody else's and it's fast. It doesn't matter. It's just how you think. You just have to practice them to get better at them. Okay. So if I think of sine 2x, I know sine 2x is going to be, and by the way, I'm going to work with this because it's easier than figuring out how to get cotangent x to be some identities over here that are double. So again, I don't know if I got cut off, but I got to change this to give me something that I can use to somehow get to where I have a sine possibly on the bottom and a cosine, and I can just make it a cotangent. Okay, so what I want to look at is this has to be an identity. I got to get rid of the double angle because I have no double angle over here. That's just an x. Right here's just an x. So I know that sine 2x is equal to 2 sine x times cosine x. Boom. 2's are gone. That double angle's gone. Now let's figure out what we want to do at the bottom. I'm going to leave this 1 minus alone. This is not an identity. There's a double angle. You have nothing that does that. So it doesn't. So don't think just because the whole denominator doesn't equal what you want to some identity. That's okay. We can break things up. Okay. And what we want to think about, especially we have a 2. If there's a 2 up here in the numerator, I got to get rid of this 2 because there's no 2 over here. So we got to think about that just as we go. Okay. Think about what you need as you go along. Well, I'm going to put, since I have a sine x and a cosine x, and I need just a cosine x on the top, and I have a sine x there, so I got to get rid of that somehow. So I'm thinking to change that double angle, I'm going to use the one that has the sine in it. So for the angle, and I'm going to use a different color, cosine 2x, I'm going to use 1 minus 2 sine squared x. Again, the only reason I want to do that, there's a 2 happening there. Also the square, the sine x on the bottom, maybe I can cancel something out. Looks like I can as long as everything comes together. So think of math and how we would simplify. At this point, I have this business right here. I'm like, what the heck do I do with this stuff? Well, we know we can somehow make this work. We can get rid of the parentheses, and we get rid of the parentheses because we have that, that minus here. So we're going to multiply everything by the opposite. So I will have 1, this 1 minus, so minus times positive is a minus 1. And then this negative times negative in front of that 2 sine squared x is going to make it a positive 2 sine squared x. Okay, so I'm just going to put that there, and I rewrote that. Okay, so, all right. So now, on the top, I still have this 2 sine x, cosine x. Just make sure when you're doing this, if you're doing what I do, work underneath, just keep it in an orderly fashion so that I can follow your work and that you can follow your work. So if I combine like terms, what is 1 minus 1? 0. What do I have left over? Well, I have a 2 sine squared x. Now, hopefully you were hoping that those two cancel, and now they do because everything on top is being multiplied and everything on the bottom is being multiplied together so that I can cancel things, which makes it beautiful because I don't need a 2. There's no 2 in my answer over here that on that side, so I will cancel out my 2's. They go to 1. Great. I have a cosine because I said if I have a cosine over sine, then I know I have cotangent. I have a cosine on top. I got to get rid of that sine x. Well, if you think that's x over x squared, you can reduce that. So I can reduce sine x by 1. I divide that by sine x becomes 1. Well, sine squared x divided by sine x is just a sine x. So now what do we have on top? We're left with a cosine x over a sine x. And lo and behold, that's cotangent, and that's what we wanted. Now you have to take the next step. You have to tell me that cosine x sine x is cotangent x, and that does equal to that cotangent x over here on the left, on the right, and it's equal. All of this, again, is your work. All of this is your work. All this work, is your answer. Everything you do is your answer because these are verified. Okay. we're going to look at this one right here. We do want you to say something really quick about this. It's okay that we have this cosecant 2x and we don't have an identity for it, okay? Because we know that, let's just do, if we have 1 over sine x, that is equivalent, the reciprocal of cosecant x. If we add 1 over sine squared x, then that would be the reciprocal of cosecant squared x. Same thing if I had 1 over sine 2x, that's going to be the reciprocal of cosecant 2x. That carries with you no matter where you go, just like we're doing. So based on that, let's use that to help us to verify this. I'm going to work on the right this time because I do not have an identity for cosecant over 2x. And if I make it a fraction, it might just be worse. And over here on the other side, it's already a fraction. So if I can think about making it to where I know that this goes with sine 2x. And I know sine 2x equals let's see, 2 sine x cosine x. Then I can, if that was in the denominator, the reciprocal of that. So if I can make that on the bottom, because the reciprocals of each other, then I can figure this out. So since this already has a fraction, I think this would be easier for me to work with. You can still change this with 1 over and try that way. It's not wrong. I just feel like to me it would be harder to do that. But also we haven't really done anything solving on the right. So let's just try it out. So what I'm going to do is just kind of clean this all up and let's just go from there. Okay, so I have this. I'm going to verify this. So what I'm going to do is I'm just going to change this. Cosecant x is 1 over sine x. And on the denominator here, I have 2 cosine x. Okay, well, I know, again, let me just write it over here. I don't know why I got a little bit. I know sine of 2, the double angle for the sine, is 2 sine x cosine x. Well, this gives me my 2. Here's my cosine sine. So I'm just going to follow the rules of multiplying fractions or dividing fractions. I'm going to keep the first one the same and multiply by the reciprocal. Remember, it's 2 over 1, so that's going to be 1 over 2 cosine x. Okay, I was just trying to make that a little bit neater. Okay, so I have a fraction, and when I divide fractions, I keep the first fraction the same, and I multiply by the reciprocal of the fraction here. So the reciprocal of 2 cosine x over 1 is 1 over 2 times cosine x. So now we're getting that where we're going to get to this cosecant because cosecant is 1 over sine. So we're going to just multiply the denominator together. Yes, the denominator together. I'm going to put the 2 in the front. Okay, so now I have the double angle for sine. So I'm going to change that to that. So that's 1 over sine 2x. Well, 1 over sine 2x is the cosecant of 2x, and therefore it equals the cosecant of 2x. So we verify that that's true. So it's just slightly different, but you think about all the other things that we do when we take the secant, cosecant of everything and sine and cosine and stuff and what they look like when they're the reciprocals.